Hello guys, welcome back to Coder Journey, episode number 2 of the Clean Architecture playlist, where we are going to not only learn the different concepts of the clean architecture, but we're also going to see how we can implement these inside of an application. So let's get to episode number 2. Again, as I have told you before, please make sure you watch the videos in order. So make sure you watch episode number 1 before watching this course. During the first 4 episodes, we are going to go through some theoretical topics. And starting from episode number 5, as you can see here, we're going to go to Visual Studio and implement every single one of the, concepts one by one and see in action what we need to do in order to be able to implement those ideas. And of course, inside of the notes that I've got here, I'm going to show you some code snippets, but the real implementation will start from episode number 5. Understanding these theoretical concepts, I think, are very important, which is why I am going to ask you to stick with me during these first four episodes so that we can understand the theoretical concepts as well as the implementations. So the domain layer sits at the heart of clean architecture. It encapsulates the business logic, right, as I told you in the previous episode, and contains the purest form of the system's rules, completely independent of frameworks or infrastructures. So everything inside of the domain layer is going to be encapsulated, and your business logic will be inside of your domain layer. And changes in the outside world, like changes to the technologies that your application takes advantage of, will not propagate to changes to your business logic, because the business logic is independent, is going to be inside of the domain layer. So we are going to talk about some of the concepts, some of the elements that the clean architecture introduces, which we are going to implement inside of the domain layer. Entities. Let's talk about entities. What are entities? Entities are objects with a unique identity. This identity persists throughout the application regardless of state changes. When I talk about state changes, I mean like changes to the property, right? The properties of a class. So when you think about entities, for example, in C#, an entity can be implemented using a class. And if that class, that object, the objects that you create based on that class have a unique identity, like a property called ID, in order to identify one object from another one, objects of the same class, those are entities. Of course, this is a very rough definition, but that's the basic fundamental idea. They typically represent real-world business concepts like user, order, invoice. This is a sample entity. So as you can see, I have used a class, right, to implement this entity called user. It has a unique identifier called ID of type GUID. It has this setter, a private setter. We are going to talk about the reason why we need to create the setters as private, because we want to protect the invariance of the entity, and we're going to talk about the invariance as well. So the properties, these together, I mean, they constitute the state of our user entity. And then of course we've got this public constructor that takes in the different values for the properties, and of course it's going to create a user object. There are other patterns that we can use when we want to implement the user entity, and I'm going to talk about those patterns one by one in the upcoming episodes. So that is the concept of entity. One very important thing that I want you to remember about entities is that entities are objects, right? Entities are objects that have a unique identity. And that unique identity, for example, can be implemented using a GUID as the property of this entity. Another concept when we are developing the clean architecture is value object. So value objects are immutable types, right? Immutable means when they are created, there is no way you can change them. They represent descriptive aspects of the domain with no identity. One very important distinction between value objects and entities. Value objects contain no unique identity or identifier. They're immutable, meaning that when they're created, you cannot go ahead and change the values inside of the properties that they have. If you want to change the values inside of those properties, you need to create another instance of that value object. Two value objects are equal if the values inside of those properties are the same. And examples of value objects are things like email, money, address. Because, for example, an email doesn't need to have a very specific ID in order to be identifiable, but rather based on the email address, based on the domain of that email address, you can say whether two email addresses are the same or not. Again, one single concept like email can be a value object or an entity inside of different projects. So again, I want you to really think about this. It doesn't mean that in every single project, an email will be a value object. Maybe in some software applications where the domain is going to be 100% concentrated on the topic of emails, for example, you will have to implement an email as an entity. Here you can see an example of an email implemented as a value object. So as you can see, again, we are using a class. We can use a record here as well. I will tell you why using a record will make more sense when it comes to implementing a value object. We will have our different properties. As you can see, the properties don't have a setter, meaning that you cannot set values to these properties after you construct an object of this value object. And if you want to change the value of a property, you need to create another instance of the value object. This is why we say that value objects are immutable. After they're created, the values inside of their properties can't be changed. And then we need to be able to see whether two value objects are the same or not. And in order to do that, what we can do is to check every single property that they have, the value inside of those properties. So suppose I want to see if two instances of the email value object are the same or not. In order to do that, what I need to do is to check the values inside of the address property. And if the address property, the value that the address property has between two different instances of the email value object are the same, we can say that those two instances are the same. This is not the case for entities. For entities, when we say that two entities are the same, we need to make sure that the ID that those two entities have are the same. So checking the equality between two entities are based on the value inside of the ID. But for value objects, the equality is based on the state, on the values that are present inside of the properties. Domain events, another concept. So domain events are used to capture something important that has happened in the domain. I'm going to show you how to implement domain events using the iNotification interface from the Mediator library. And you can learn more about the Mediator inside of the in another course that I've got called CQRS, I think, and Mediator. I have talked about the iNotification interface there. This interface is used to implement domain events. So domain events, they represent important things that have happened inside of your domain, things that need to be addressed, things that other parts of the application need to address, need to handle, need to do something in response to. They help achieve decoupling between different parts of the system. So using domain events, you can publish a domain event and other parts of your application will react to that event. They do not need those different components or those different types of your parts of your application don't need to be coupled to one another. So for example, as you can see again here, I've used the class to implement a domain event. Again, of course, I told you we are going to use the iNotification interface coming from the mediator library to introduce a domain event. And inside of this domain event, we are going to have like a constructor and a property. Domain events are usually implemented using records in .NET, and we will see why. The next concept, domain services. Domain services hold domain logic that doesn't naturally fit in an entity or value object. So if you've got like some business logic that you're not sure where to put, they do not fit naturally inside of a value object or an entity, they need to go to services, domain services. They usually operate on multiple entities or coordinates complex operations. So again, as you can see here, I've got this payment service. It's going to be a class. It has this method. It is using the user entity. It is using a decimal value, and then it is doing something. So because this process payment cannot naturally fit inside of a user entity, I have decided to put it inside of this service. Interfaces. Interfaces in the domain layer define contracts for dependencies like repositories, external services. This allows the domain layer to remain decoupled from the actual implementation. So for example, as you can see here, we are going to have a repository interface called iUser repository, and the implementation of this will be in another layer. So here inside of this domain layer, we're going to have the contracts, the abstractions, the interfaces of these repositories or external services, and the actual implementation will be somewhere else. I'm going to show you again how to do this in the upcoming videos. Exceptions. Domain-specific exceptions. Based on the domain of the application, maybe you will need to introduce custom exception in order to encapsulate specific business rules and their violations in meaningful ways. So for example, suppose I'm working on an application where an email needs to be evaluated. So I can, for example, introduce a custom exception called invalid email exception. And then for this specific domain, I will be able to use this very specific exception rather than relying on the generic exceptions that, for example, .NET or any other framework provides. Enumerations. Enumerations represent a set of named constants. I think you're familiar with this, right? If you have worked in C#, if, I don't know, you know a thing or two about object-oriented programming, of course you have come across enumerations. So these encapsulate domain concepts like, for example, order status, pending, completed, canceled, user role, administrator, manager, I don't know, user, guest, and so on. So for example, as you can see here, we've got this enum or enumeration called order status with 5 different values. These components, these different concepts, enumerations, entities, value objects, domain services, domain events, right? So these form the foundation of your domain logic and are completely independent of the UI, the database, or frameworks. We're going to see how to implement each one of these concepts inside of the application that I showed you, that I told you about. So again, as I have said before, if following these theoretical videos are a little bit boring, please bear with me, because from episode number 5, we are going to get to Visual Studio and implement each one of these one by one. Thank you so much, guys, for watching this video till the very end. I hope you've enjoyed it, and I'll see you in the next one.